All right, as some of you know, I do work over in the Grand Lake St. Mary's watershed over on the western side of the state. And we write a lot of nutrient management plans on that side of the state. We write a lot of CNMPs. And some of the things that we've learned over the last couple of years, writing those plans are some very important inputs, make those plans decent as a product for the farmer. And trying to balance the nutrients, because we do have a lot of manure over there with commercial fertilizer, has been quite a challenge. Trying to understand the different types of fertilizer and the application rates and timing has also been a challenge. Pairing that with the seasons that manure application goes out. So one of the biggest things when we started working in that distressed watershed is we didn't have very many soil tests. And some of the soil tests, the majority of them coming in were pretty spotty and not very accurate. So we're a couple years into this. We've done quite a bit of training to get good soil samples so that we can have some good input going into figuring out the soil nutrient needs. The other part of that was knowing the recommended soil test level ranges. We have very high soil tests over there, and so we're trying to figure out, okay, how much manure can we continue to put out there? Trying to figure out the crop removal rates. We have some guys saying, I pull my soil test down so fast that I keep having to put nutrients out there. So knowing removal rates for potassium and phosphorus, and then also understanding the drawdown of phosphorus. How much historical phosphorus do we have in the soils, and how long is that going to take to draw that down to what we would consider a needed or critical maintenance level? Knowing your manure and analysis, I'm going to show a couple slides here in a little bit. I'd never heard of taking a manure analysis until a couple years ago. We didn't really see much of a need in it. And now it has shown why it's very important. Part of that goes back to what the animals are being fed and the diets. And depending on what the animals are being fed, that'll drastically change the manure analysis. And then also looking at applying nutrients accordingly. So one thing that we learned quite a bit, even the folks in the offices that are trying to help with the farmers coming in, is understanding soil test reports. On a normal basis, we have about 6 different labs that we're dealing with, and each one of them have a different reporting method. So trying to figure out how those soil tests are coming in, what the soil test says, and what it means. There is a fact sheet that OSU has put together. It's a 2-page fact sheet. It's nice. It's real simple to read through. It basically explains where your soil test, how to interpret reading a report. The 2 most common mistakes, and our staff that deals with this every day, we still struggle with trying to figure out which way the reporting methods are used, is the soil extraction type, whether it's in Bray P1 or Malick 3, and then the soil test units reported in pounds per acre or parts per million. There is some conversions that you need to use based on, depending on how the soil test is coming back. So one of our biggest problems is recognizing whether it's in parts per million or pounds per acre, and there's a simple math to multiply by 2 to get that. But looking at soil test reports, we had a lot of guys that thinking, hey, our soils are okay. They were reading them in parts per million. Right away, when you start doubling those, their 100 part per million soil test is now 200. So the other thing that you guys have heard 5 times over today is utilizing the Tri-State Fertility Guide. Obviously, that's what our recommendations are for the state of Ohio. It's the best thing that we have to take a look at that. It does account for your planned crop, your yield goals, and your current soil test. So you can Google that. It is online. It's very easy to read through. It's not very long, and it's specific to what crop you're putting out. So in the Tri-State Fertilizer Guide, there is a fertilizer range recommendation. The soil test level below this critical level, basically if your soil tests are in there and you apply manure or nutrients, you're probably going to see a yield boost in that up until you get to the critical level. There's times when I've seen just putting a little bit of fertilizer out there, they're just so low that the crops have an immediate response. And then you have the maintenance range that's right in the middle. And The critical level varies between crops, and that's one thing in our area. We do a lot of alfalfa, and we do quite a bit of wheat also for bedding. Some areas that are only using corn and beans, your maintenance ranges are going to be a little bit different. They have to be higher to account for the cold weather for those crops that are growing through the wintertime. So alfalfa and wheat growing through the wintertime, they're going to utilize that phosphorus more. There is no yield response expected when you're going to fertilize above that critical level. But the question always comes into play, why is that maintenance range so wide? Why is there a big area? Well, it's basically a safety factor. You're looking at the maintenance plateau safeguards against sampling or analytical variation. So if you have some areas that are making that soil test go off a little bit, just for security factor, that's why that maintenance range is so wide. So when we look at the phosphate recommendations coming out of the tri-state, again, you need to really pay attention. Are you reading in the parts per million column or the pounds per acre off your soil test? It gives you both. You just have to know how to read your soil test. So we go back to the maintenance ranges for corn, silage, corn and beans is 30 to 60 pounds per acre. Wheat and alfalfa is 50 to 80 pounds per acre. So in the tri-state removal rates, we're looking at using the average yield for phosphorus and potassium once the critical soil level is achieved. So once you've met that minimum requirement on the soil test, we need to get pulled away from using the yield goals, because typically in a 10-year time frame, we're probably going to have a dry year. If we don't have a good crop, that's not going to utilize the nutrients that are there. They're going to be left over. So we really need to be looking at the average yields during those time frames to utilize and project how much you're going to be removing. So it's real simple. You take your average yield goal and you multiply it by the bushels. So if you're getting 175 bushels of corn, you're going to take that phosphorus removed as 0.37 pounds per bushel. And then this also counts for any grain or straw and alfalfa that was removed. So we're going to refer back to that chart in a minute. I'm going to go through an example. As I think every speaker in the room has said today, or almost everyone, we're talking about accurate manure samples. And I don't want to keep repeating what everybody's said all day today. But taking a good sample, if you're taking a solid sample, put it in a bag. If you're taking a liquid sample, use a bottle. Make sure you're labeling those. I have guys that have multiple samples they're taking in. They might be taking 2 or 3 holding bond samples in at the same time from different farms. Make sure you label which one those are coming from. Take a representative sample. I think Kevin alluded to something with manure samples being pulled off the top versus a representative sample of that material. And one of the biggest benefits that we've seen in the Grand Lake watershed, we're required to pull annual manure samples. What we can do is we can take, now the rules have been in place for a couple years, we can take 5 or 6 of those samples and average them for a farm, or we can pull out a bad sample and say, hey, you have 3 really good samples, but this sample over here, for whatever reason, that's not a good sample. So we can average the 3 good samples and get something representative for their manure. It's very important that you pull your own samples and not rely on your neighbors, especially when we're looking at dairy manure, because it's going to vary depending on how many gallons are being used through the milk parlor, how much concrete lot runoff you have, how diluted that material is. So when you're looking at dairy manure especially, those samples are going to vary a lot. Timing and pulling of a sample. In an ideal world, it would be great if we could pull a sample. We have the equipment there, we agitate it up, we pull the sample, we take it to the lab, we get the results, and then we do the manure application. But I think we all know that that's really not going to happen. That's why it's important to have those averages. You can go back to what you had last year, still pull a sample, but keep that in mind for future, because if you go there and you pull a sample and you haven't agitated the pit up, it's not going to be representative, and we see it all the time in the samples that we get in the office. We can tell just by looking at the sample. If the sample's been agitated, if it's been pulled in a bad spot, if it's not a good sample, if it's too dry, too wet, diluted down, you can just pick them right off the top. And the last time I checked, the manure samples are costing around $34. That's probably going to depend on the area that you're in, but in my opinion, it's pretty good money spent. So when we look at I know you guys can't probably read this, but the average manure samples, because we're required to take manure samples over our way, these are all the ones that we've averaged for about the last 6-8 months. So all the samples that we've received through the door, which are a couple hundred depending on the type of animals that we're dealing with. But if we would have done this a couple years ago, when I first started, our average for hog manure at the time was 30 to 35 pounds per 1,000 gallons of hog manure for phosphorus. And our samples right now are coming in at 23 pounds of phosphorus per 1,000 gallons. So when you're looking at a manure application rate, you go from 23 to 35. That's a big difference on how much phosphorus you're putting out there per 1,000 gallons. And then we're also looking at the moisture content in that manure as well. That really plays in with the steer manure on how wet that material is coming out. That can affect the nutrients. And once you consider the burn off of all that moisture, it can really play into the amount that you're supposed to be applying. So poultry manure, in this example, in the past we've had some variance in different types of poultry, whether it's pullet manure, turkey manure, hen manure, layers. It really depends on the type of poultry manure. But if you look at these samples, this last batch that we run over last year, there's really not a whole lot of difference. There's a little bit of difference in some of that phosphorus, but just keep in mind, if you're receiving poultry manure, you want to make sure that that sample that you're being provided or providing to somebody else is truly representative of that poultry manure, because it's not all created equally. So the biggest question is knowing how much manure to apply, removal of phosphorus, matching your manure application rates up, and trying to make a reasonable application rate. And we're not going to talk a whole lot about nitrogen. That's a whole other topic in itself. But the biggest thing is realizing that if you're not sure how to calculate some of this, please do ask somebody. We have a lot of people across the state that can really help and answer some of these questions. So when we get to some math here, this is the example that I wanted to go through. I wanted to focus on, we deal a lot with a higher soil test level. So we have guys come in, and it's really hard for us to relay to them how much phosphorus they have in the soil. So I'm going to give you an example here, and it's going to give you a little bit different perspective, because we've always heard, you know, it's going to take you 5 years to pull that down. You can only remove X amount of pounds per year per crop if you don't apply anything. So this example here is going to use an average yield goal for a corn-soybean rotation. So we have 175 bushel yield goal for corn. We take that, and you take that 175 and you multiply that by that 0.37 pounds of phosphorus removed per bushel. That's going to equate to right at 65 pounds of phosphate. And if you do that same equation and you take the potash removal, you're going to remove about 47 pounds of potash for that year's crop. And then if you have the second year, you have beans in your rotation, you're going to take 50 bushels as an average, and you multiply that by the 0.8 removed per bushel. That equals 40 pounds of phosphate and 70 pounds of potash. So let's add those up, because that's a 2-year rotation. So we're going to take the 65 plus the 40 equals the 104.75. Divide that by 2. So in a 2-year rotation of corn, soybeans, on an average year, you're going to remove 52 pounds of phosphate, 59 pounds of potash. So let's take a look at a manure application to meet that. So we're looking at the manure sample to get the pounds of phosphate per 1,000 gallons of manure. So typical 2,400 head hog building, they vary in their production based on their watering system and the management of the barns, but let's just say it produces 700,000 gallons a year. That 700,000 gallons times your 23 pounds of phosphate per 1,000 gallons that you get off the manure sample equals 16,100 pounds of phosphate produced per year out of that hog barn. And then we're going to take that and we're going to divide that up with this corn bean rotation. Your average removal is 52 pounds per year, so you're going to need, on average, 310 acres to utilize that phosphorus and just balance it. It's not going to be in a drawdown or build up, it's just going to balance it. We're going to do the same thing for that potash. You take that 700,000 gallons and you go through the calculations and you're at 308 acres. So that's pretty close. So we're looking at 310 acres. You can utilize the Tri-State's required potash and phosphorus needs. So at the end of the day, it shoots out this number and it says, okay, you need 2,258 gallons per acre application rate on 310 acres. How many guys are going to apply that every year? Who's going to cover 310 acres at 2,200 gallons? I don't think I would, and I'd have a real hard time telling somebody else to. So it's not really a feasible application rate. But once you start bumping that up, then you're going to really need to consider some of your other aspects. You're going to need to look at the time of year that you're applying, the nitrogen that you're applying. So then we bump it up, and let's just say we're going to double that to 4,500 gallons and cut your acres in half. Is that feasible? Maybe with a tanker. So those are the things that you really need to take a look at when you're looking at the nutrients. Are you trying to do a 2, a 3-year rotation? Because we'd really try not to put more nutrients out there than for a 3-year rotation. So knowing what is in that manure sample really plays a lot into how many gallons per acre you can be applying. So when we look at the rule of thumb for nutrient drawdown, this has kind of been all over the board, at least the experience that we have. We have guys bringing samples in saying, hey, I've planted alfalfa for 6 years now and I've drawn my soil test down this many pounds. And we're like, there's no way. And so our general rule of thumb that we've been using is 10 pounds of phosphate removed in a harvested crop drops the soil test phosphorus by 1 pound per acre. General rule of thumb. So if we had that 2-year crop rotation where we're removing 52 pounds, hopefully we can drop that soil test by a couple pounds there. So in a typical soil test, phosphorus may move 3 to 7 pounds depending on the crop and how much yield you get out of that per year. So that leads into the next question. This is what I call the Terry Mesher calculation, because he did this at a training, and this really put a different perspective on how I kind of look at explaining nutrient drawdown to farmers. If we have a soil test level that's 150 pounds per acre, how many years will it take to draw it down to 80 pounds using a corn-soybean rotation? So there's 70 pounds difference. We take the 150 minus the 80, which is the high level of the recommended range. You take that 70 pounds times 10 pounds of phosphate, which is your removal, equals 700 pounds of phosphate. That 700 pounds divided by the bushel calculation, that means that you have enough phosphorus out there without adding anything. That's including starter fertilizer for 1,892 bushels. So what does that equate to, utilizing your average bushel per acre year? You have enough manure out there for just under 11 years, or fertilizer out there for 11 years. So what that means is if you have a soil test level at 150 and you want to draw it down to 80, you put no commercial fertilizer, no manure, you're going to have enough nutrients out there at a minimum to reach the high end of the maintenance level for 11 years. If we go to a corn, I'm sorry, that last example was a solid corn sample. This one is a corn bean rotation. So the beans are going to utilize a little bit less phosphorus. So at the end of the day, we're looking at 13 and a half years. So you add on right at 2 years just by putting another crop in there that utilizes less phosphorus. So when we're looking at the higher soil test levels in my area, this is some of the considerations that we have to have. But when we have livestock manure and limited places to go, that's going to be extended out several years if you're still applying some manure. So let's say you still have to apply manure every couple years to that. That's just going to add on how many years of manure that you have available. So the other part of that is, today I've asked a couple people what do they consider a high soil test level. I've gotten 3 different answers. I've gotten 60 pounds of phosphorus, I've gotten 120 pounds, and I've gotten 200 pounds. So what is a high soil test level? In our area, I'm happy if a guy brings a soil test level in below 150 pounds per acre. So up, maybe up here is a 60 soil test level high. I don't know, but at the end of the day, it's good to have this information to know how many nutrients you're putting out there. So in summary, you don't have to be a crop consultant to figure some of this out. The calculations are really simple. They're in the tri-state. With a small amount of information, you're going to have a few bucks out of your pocket to run a manure sample. Spend some time doing some calculations. Spend some time making sure that if you're pulling your soil test levels or soil samples, that they're good samples. And spend some time and work with the people that are pulling them if you're not. Understand how much manure you're applying. Take credit for all your nutrient applications. Like I said, those examples weren't even utilizing starter fertilizer. And again, knowing what you're actually applying out there. And like I said, we won't talk much about the nitrogen because there's a lot of different variables that play into that. And when we're looking at applications, we really do focus on a lot of the phosphorus and potassium.